Howdy! This is your friendly neighborhood physics teacher here, and I'm here to do some dimensional analysis homework. So, now, first one I'm going to do is with Sally Leadfoot. And the speed limit is 65 miles per hour. And when the cop stopped her, said that she was going 276 kilometers per 68 minutes. Now, that we have kilometers and minutes, and we need miles an hour. So we're going to focus on the kilometers first. So for 276 kilometers, we need to get that into miles. We look in our handy dandy chicken duck. Yep, hopefully you find it. There is a conversion from kilometers to miles. So for 1 kilometer, there's 0.621 miles. We have a kilometer on top. We have a kilometer on bottom, so therefore they cancel. All you have to do is multiply across the top, multiply across the bottom. So across the top, you get 171.396. Don't forget the miles over 1. So that just gives you 171.396 miles. Now let's focus in on the minutes. So it says that she was traveling at 68 minutes. But we don't need minutes, we want hours. So minutes need to go to the bottom because we want them to cancel. We need hours on top. So for 1 hour, 60 minutes. Minutes cancel. We want hours. So we multiply across the top, multiply across the bottom. Then divide. Don't forget about your hour. Then you divide, and you get 1.1, lots of threes, hour. So now we have miles and we have hours, but we need to know miles per hour. What does that per mean again? Yep, means divide. So we have to do 171.396 miles per 1.133 hours. So you plug that into your handy dandy calculator, and you get 151.28 miles per hour. Now, I would say she deserves a speeding ticket, especially speeding if she's going that much. So remember, speed limit was 65. She's going at 151. Yeah, that's very fast. But if you want to convert that, put that into scientific notation, this is in standard form. And to put it in scientific notation, we have to move the decimal 1 2 times. Now remember, when you're going from a bigger number, so 151.28 is bigger than 1.51. That's smaller. So when you're going from a bigger number to a smaller number, that means you're going to, means your number is going to be positive. So we moved it 1, 2, so it becomes a positive 2. Remember, that is an exponent. Exponent. So our answer becomes 1.51 times 10 to the positive 2 miles per hour. There we go. So my next question I'm going to do is I'm going to do the which one do I want to do? I want to do the one that we're converting from 98,153 centimeters, and you're trying to get it into miles. So, if you look in our chicken duck, we do not have a direct conversion from centimeters to miles, but we can figure this out. We'll just have to take more than just one step. You always put your given here. We don't want centimeters, so centimeters have to go to the bottom. But if you look in your chicken duck, there is a miles to kilometers, but there's also, we can also do a miles to inches. So let's see, there is a miles to inches. So let's see if there is a centimeters to inches in our chicken duck. Let's look to see if there is a centimeters to inches in our chicken duck. There is, dun 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 dun. So if we look, we have for 1 inch. So for 1 inch, go away, we have 2.54 centimeters. Now, in theory, you can flip this. If you look at our chicken duck, it also has centimeters to inches. And you can say for 1 centimeter, there's 0.3937 inches. So either way would have worked. We just want the centimeters on bottom, so the centimeters can cancel. So now we can go from inches to miles. We again look in our handy dandy chicken duck. Does have an inches to miles, so for 1 mile there's 63,360 inches. That goes from, make sure inches on top, inches on bottom. So we have our miles. Multiply across the top, multiply across the bottom, multiply across the top. It's just the same because 1 times a number, just a number. Don't forget about your units. Multiply across the bottom. 4 times 3. You get this lovely number. There's no units. And then divide. And you get 0.609. Now you can round that to be 0.61. The reason I left the 9 is because we want to put it into scientific notation. So remember, this is standard form. That's standard form. We forgot our units. If we want to put into scientific notation, the decimals got to go behind the 6 because we want one number that's not a 0 in front of the decimal. Now again, let's look at this. So 0.609 is smaller than 6.09. So we're going from a smaller number to a bigger number. That means our exponent is negative. So we moved it once and it becomes a -1. So our answer is 6.09 times 10 to the -1 miles. And that is our answer. So now the next one I'm going to do is the one you kind of had to fill in the blank. So we gave you the pathway and you had to fill it in. This one is harder than a lot of people thought because we are forcing you to go a certain pathway. So we gave you your starting point and we said grams, and we wanted you to go from grams to pounds, and then from inches to centimeters, and then from inches to feet. So we have to make sure that everything cancels. So grams cancel, grams cancel. I forgot to write centimeters down here. 1 centimeter. Centimeters cancel, centimeters cancel, inches cancel, inches cancel. So therefore, our answer is going to be pounds per feet. And that's what we wanted. But at this point in time, you had to sit there and look in your chicken duck and see what conversions go with what. Hopefully the last one was easy, 12 inches into 1 foot. We've been using that a lot. The centimeter one could go either way, remember? So remember we had that 1 inch is 2.54 centimeters, but what the numbers we gave you is for 1 centimeter is 0.3937. And then this is the one that caught a lot of everyone. This is the one that stumped a lot of people. Because if you look in your chicken duck, there is a conversion from pounds to kilograms. So for 1 kilogram, that equals 2.204 pounds. But we don't have kilograms, we have grams. But we have that 2.04 pounds given to us. So then you have to think, how many grams go into 1 kilogram? Hopefully you said 1,000. So that's where that comes from. So 1,000 goes here, and that 2.204 goes there. Of course, then our answer is like 42 point something. Okay. So that was the drag one. The reason this one was so hard is because, one, we are forcing you to go down a path. You don't get to pick your own path. And two, you had to do a nice little metric conversion in the middle of it, which threw a lot of people off. So the next one, I believe this is our last one. Nope, second to last one. We are going to convert 98 miles per hour. So you can write it like that, or you can write it miles per hour. And we want to convert it into kilometers per second. We want to go to, meters per second. Meters per second. We want to go to meters per second. So, nope, I want to erase that, right? So this one I'm going to do in one long, big railroad track. I'm not going to split it up. So at 98 miles per 1 hour, we're going to focus in on the miles first. So there's not a direct conversion from miles to meters, but there is a miles to kilometer. So miles to kilometer. So for 1 mile, it's 1.609 kilometers. Makes our miles cancel out. But we don't want kilometers, we want meters. So we know we can go to our metric stairwell, know that there's 1,000 meters in 1 kilometer, which causes our kilometers to cancel, and we want meter. Now we have to go back to our hour. So we didn't want hour, we want seconds. So hours have to come up here. We want second. Why does the hour have to go up there? Because it needs to cancel. We have one on bottom already, so it needs to go on top, so it cancels. So for 1 hour, there's that many seconds. So at this point in time, you just multiply across the top, multiply across the bottom, and divide. So across the top, you get 2. And across the bottom, 1 times a number is just that number. And then you divide. Do not forget about your units. So then you divide. And you get 39.78 meters per second. Remember, this is in standard form. We want in scientific notation, so you have to move the decimal once, going from a bigger number to a smaller number. So it's positive, so our answer is 3.98 times 10 to the 1 meters per second. Last but not least, we want to convert Yes, I was making sure I didn't miss anyone. We want to convert the 258 kilometers per hour, and we want to convert that into yards per minute. So I'm going to do the two-way again, break it up into two different parts. So we're going to focus in on the kilometers first. So 258 kilometers. We need to get that to yards. Looking in our chicken duck, there isn't a direct conversion from kilometers to yards. So we can go from kilometers to meters though, because there is a conversion from meters to yards. So again, 1,000 meters, 1 kilometer. Makes our kilometers cancel out. But we didn't want meter, we wanted yards. And for 1.094 yards into 1 meter. Meter on top, meter on bottom, cancels out. We want yards. Very good. So now we just multiply what's across the top. So multiplying across the top, you get 2,8,200. Yeah, that number, fun number right there. And that's yards. Ran it over. Now let's focus in on the hour. There's not a number with hours, so we know it's 1 hour. We're trying to get it to minutes. We want hours to go away, so hours have to go on the bottom. We know there's 60 minutes in an hour. Our hours cancel. So we're just left with 60 minutes. But we want yards per minute. So what do we need to do with those two numbers? Divide. So we have this horrible number, divide by 60, but that is yards per minute. So when we divide those numbers, you get 4,704.2 yards per minute. Now, that's in standard form. We went in scientific notation, so we move the decimal 1, 2, 3 times. We're going from a bigger number to a smaller number, so it's positive. So our answer becomes 4.70 times 10 to the 3 yards per minute. So I hope that helped you out. Don't forget, anytime you're doing dimensional analysis, there's multiple paths you can take. Even on this one, I went from kilometers to meters, meters to yards. I could have gone from kilometers, like kilometers to miles, miles to yards. There's all kinds of different ways I could have done this track. So just have a good idea on your conversion chart where everything is, so it doesn't take you very long. And hopefully you have a wonderful day. And don't forget, if you need any other help, still don't understand it, ask. That's why we became teachers. So again, have a wonderful day. Bye.